Hello! In today's lesson, we're looking at special right triangles. Our objectives are to find the side lengths of special right triangles and to use special right triangles to solve real-life problems. Vocabulary: special right triangles. Special right triangles are right triangles whose angle measures are 45 degrees, 45 degrees, 90 degrees, or 30 degrees, 60 degrees, and 90 degrees. Theorem 9.8, 45 degree, 90 degree triangle theorem. In a 45 degree, 90 degree triangle, the hypotenuse is square root of 2 times as long as each leg. So the hypotenuse is equal to square root of 2 times the leg. Theorem 9.9, 30 degree, 60 degree, 90 degree triangle theorem. In a 30 degree, 60 degree, 90 degree triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is square root of 3 times as long as the shorter leg. So the hypotenuse is equal to 2 times the shorter leg, and the longer leg is equal to square root of 3 times the shorter leg. Example 1, finding the hypotenuse in a 45, 45, 90 triangle. In this question, we are to find the value of x, and we can see over here that x is our hypotenuse because it's right across from the right angle. By the triangle sum theorem, the measure of the third angle is 45 degrees because we know this is 45, we know this is 90. 90 plus 45 and then subtracted from 180 gives me the other angle as a 45 degree. So the triangle is a 45, 45, 90 right triangle. So the length x of the hypotenuse is square root of 2 times the length of the leg. We have the measure of the leg. Each leg is 7, so we know it's square root of 2 times the leg using the 45, 45, 90 triangle theorem. From here, we just substitute in the value for the leg, which is 7 times square root of 2. We can't multiply 7 and square root of 2. Actually, we can, but we'll get a decimal answer. But let us leave our answer in radical form. So we're going to move the 7 just outside of the square root of 2 so that we get 7 square root of 2. Example 2, side lengths in a 30, 60, 90 triangle. Find the values of S and T. Because the triangle is a 30, 60, 90 degree triangle, the longer leg is square root of 3 times the length of the shorter leg. If I look at what I'm given in my triangle, I know that it's a 30, 60, and 90 degree triangle. I don't have my hypotenuse, and I don't have what it seems to be like the short side of the triangle. I am given the long side of my triangle, which is 9. So since I don't have the hypotenuse and I don't have the short side, what I'm going to start working with is the long side of this triangle, and I know that the long leg is equal to square root of 3 times the short leg. So let's substitute what I know. I know that the long leg is 9 and it's square root of 3 times s. Isolate s by dividing both sides by the square root of 3. So I now have 9 divided by the square root of 3. I am not allowed to have a radical in the bottom of a fraction, so I need to rationalize this fraction. To rationalize this fraction, I am going to multiply the top and bottom of the fraction by square root of 3. So multiply numerator and denominator by square root of 3. From here I can simplify. 9 times square root of 3 is just going to be 9 square root of 3. Square root of 3 times square root of 3 is square root of 9. Square root of 9 simplified is 3. I can simplify my 9 and 3. 9 divided by 3 is 3. 3 divided by 3 is 1. I'm left with 3 square root of 3 as the measure of my short side of the triangle. Once I know what the short side of my triangle is, I can now use that to find the hypotenuse because I know that the length of the hypotenuse is twice the length of the short leg. So the hypotenuse is 2 times the short leg. Substitute what I know. I know that's 2. I know that the short leg we just found is 3 square root of 3. Multiply 2 times 3, you get 6 and square root of 3. Example number 3, finding the area of a window. The window is a square. Find the area of the window. Well, if it's a square, then we know that all sides of this window have the same measure, which means that this is an isosceles triangle, which means that this is also a 45, 45, 90 degree triangle. First, find the side length S of the window by dividing it into two 45, 45, 90 degree triangles. The length of the hypotenuse is 36 square root of 2 inches. Use this length to find S. So We know the formula to find the hypotenuse of a 45, 90-degree triangle is s times the square root of 2, or you could say the square root of 2 times s. So we're going to use this formula and plug in what we know. We know that the hypotenuse is 36 square root of 2. We don't know what s is, but we know that s is going to multiply by square root of 2 to find this hypotenuse. And we know this because we're using the 45, 90 triangle theorem. Isolate s by dividing both sides by the square root of 2. And I'll do my work over here. 36 square root of 2 divided by square root of 2. Square root of 2 divided by square root of 2 is 1. 36 times 1 is just 36. So my side length is 36. Once I figure out what my side length is, I can now use that to find the area. Formula to find the area of a square is side times side, or side square. So it is 36 square. 36 square is 1,296. The area of the window is 1,296 square inches. Alright, checkpoint problems number 1, 2, and 3 are yours. In each of these questions, you are to find the values of the variables. In problem number 1, you need to find x and y. In problem number 2, you need to find a and b. And in problem number 3, you need to find m and n. Alright, that's it from me. I'll see you all soon.